Hello, my name is Isaac Wenger, and this is Lab 5 of Physics 2211. The purpose of this lab is to observe the motion of a ball as it is thrown and talk about the physics involved. Some of the physics that are present is Newton's second law, which states that the momentum of an object remains unchanged unless another force acts upon it. And then another force, or another way you could look at the video, is through the energy principle. Which states that the change in energy is the work done plus the heat exchanged to the surroundings. The result of the video is that the ball takes on a curving motion as it is in the air. Here is the video. It is just a boy and a man throwing a ball. So, some equations is Newton's second law, which states that the force is equal to momentum over the change of momentum over the change in time. From there, you can derive the velocity update formula, which states that the final velocity is equal to the initial velocity plus the net force acting on the object divided by the mass times the change in time. You can also derive the position update formula, which states that the final position is equal to the initial position plus the average velocity, which is equivalent to the final velocity in some cases, times the change in time. Or you could look at this video through the energy perspective, and you would use the kinetic energy and potential energy equations. So kinetic energy states that is 1/2 mass times velocity squared, and the potential energy is the mass times gravity times the y position, or the height. Here is the video in Tracker. So as you see, the ball took on a curving motion, and it's reflected in the graph. So some data. The left graph is the y position of the ball as it travels through the air, and the right graph is the y position along with the velocity in the y direction of the ball. Disregard these dots, I couldn't get them to go away. So as you can see, the ball starts from 0, and it goes and it goes and goes until it hits the apogee, or the final position it can get to. So from an energy perspective, the ball is thrown with an initial velocity, and it is slowly converting that velocity, or that kinetic energy, to potential energy up until there is there's only potential energy and no kinetic energy. And from there, as the ball continues its path, it'll convert the potential energy to kinetic energy until it is caught and stopped by the man. This is noticed in the right graph. So as you can see, the pink is the velocity of the ball. So as soon as that velocity hits 0, that is the maximum height that the ball achieves. And from there, as the kinetic energy, or as the potential energy is getting converted to kinetic energy, it just goes down and down and down. You can see the conversion happening. So initially the velocity starts off small, and then it goes and goes and goes. This is an accident. I don't know why it's like this. But yeah. So what does this prove? This proves that gravity is a force that acts on objects. Without gravity, objects would just float aimlessly until they contacted another object and changed direction. What would happen if a kid threw the ball as hard as he could to the man? So how would this change the graph? If the boy threw the ball as hard as he could, then the graph would show a much straighter line. There'd be less of a curve. This is because there'd be a lot more velocity in the x direction. So the ball arrives at the man, or to the man, quicker. This gives the gravity less time to act on the ball, so it has less of a curving motion. It would be straighter. Yeah.